Alright, welcome everyone. This afternoon we are going to be looking at how to calculate or how to determine the empirical formula of a given compound. Now, as we all know, empirical formula shows the simplest ratio of each of the various elements or atoms that forms a particular compound. Now, from the question given, we are being asked to determine or to find the empirical formula which on analysis lists the following as reacting masses. Carbon is being given as 2.0 grams, hydrogen is 0.34 grams, and oxygen is being given as 2.67 grams. Now, in order for us to perform these calculations, we must take note of two things. First of all, we must take note of the reacting masses of each of the various elements that makes up the compound. And then secondly, we must take note of their relative molecular mass of the various elements. So let's solve now. Now we say solution. Step 1, we have to list out the various elements that makes up the compound. What are the elements that makes up the compound? We have carbon, hydrogen, and oxygen. So we put it here, carbon. Alright, second step is to state their reacting masses. So we can come here and say reacting masses. Reacting masses of the various elements. Now that of carbon is 2.0, that of hydrogen is 0.34, and that of oxygen is 2.67, all in grams. Now the third step is to divide by their relative molecular mass. So we can come here and say the relative molecular mass. Now the relative molecular mass for carbon is 12, that of hydrogen is 1, and that of oxygen is 16. Now, next step, if we use our calculator, we check 2.0 divided by 12. We have 0.1666, which we can approximate to 0.17. And then if we do 0.34 divided by 1, we have 0.34. And then if we do 2.67 divided by 16, we also have the 0.17. Now the next step is to divide with the smallest possible number. Now this is 0.17, this is 0.34, and this is also 0.17. Now you check, between 0.17, 0.34, which one is smaller? Now 0.17 is smaller than 0.34. So we have to divide through by the smallest, which is 0.17. So we divide that by 0.17, we also have to divide that by 0.17, and we do the same thing, we divide that by 0.17. Now the last step, 0.17 divided by 0.17, this is 1. 0.34 divided by 0.17, this is 2. And then this automatically will give us 1. So from calculation, it can be said that carbon is 1, hydrogen is 2, and oxygen is 1. So this is the empirical formula of this given compound. Alright, welcome back everyone. This afternoon we are going to be looking at how to determine the percentage by mass of an element that is being present in a given compound. Now let's take for example, we are being asked to calculate the percentage by mass of all the component elements that makes up sodium trioxonitrate 5. Now this is the chemical symbol for sodium trioxonitrate 5. Now in order for us to, next step is to calculate the percentage by mass of the various elements. Now we say percentage by mass of sodium will be equal to the mass number for sodium, which is 23, all over the relative molecular mass of the compound, which is 85, times 100%. Now 23 divided by 85 times 100% is going to give us 27.0%. So this is the percentage by mass of sodium in this very compound. Now we move to the next element, which is nitrogen. So the percentage by mass of nitrogen will be equal to the mass of nitrogen, which is 14, all over the relative molecular mass of the entire compound, which is 85 times 100%. Now 14 divided by 85 times 100% will automatically give us 16.5%. And the last step is that of oxygen. So the percentage by mass of oxygen, remember oxygen is having 3 atoms, will be equal to 16 times 3 all over 85 times 100. 16 times 3 divided by 85 times 100 will automatically give us 56.5%. So these are the percentage by mass of the various elements. This is the percentage by mass of sodium, which is 27.0%. This is the percentage by mass of nitrogen, which is 16.5%. And this is the percentage by mass of oxygen, which is 56.5%.